Alright, in this video you're going to be talking about the graphs of sine and cosine functions. So what we see here is a graph of a sine function. So the sine function, the graph, looks very different than pretty much any other graph you've probably seen in an algebra class. So there's a few key features of the sine graph. One is called the amplitude. And what the amplitude is just the distance between this horizontal axis, right? In this case, it's the x-axis, and the maximum value of the graph. So that distance there, as well as this distance here, these are both equal to each other, and each of these is an amplitude. Okay, so as far as we go to positive x or to negative x, the amplitude for the sine graph will always be the same. In this case, the amplitude has a value of 1 because it reaches positive 1 and negative 1. The next feature of any trig graph, but in this case a sine graph, is called the period. Okay, we say that all trig graphs are periodic because they go through, they repeat the same path. And each time that path is repeated, we call that a period. So if we start the sine graph here and follow it along to the right along the positive x-axis, we see that at 2 pi, the graph begins to repeat itself. So what we'd say here is this distance from 0 to 2 pi is a single period of this graph. So we would say the period length for this graph is 2 pi. Similarly, we could have taken the period length starting at negative pi and gone to positive pi, because what we'll see is if we start at negative pi and go to the right, once we hit positive pi, that's when the graph begins to repeat itself. So what you could do is we could take any position on the sine graph, on the curve, and once it starts to repeat, that is equal to 1 period length. And for this particular graph, the period is always going to equal 2 pi. Now, this graph is kind of in its most basic form, y equals sine x. Now, there's no transformations that have yet occurred to this graph. So sometimes, many times, there will be transformations. This particular graph does not yet have any transformations. So all of the transformations that occur are very similar to what we saw back in Chapter 2, Section 7. All right, a couple more notes about a sine graph. So a sine graph, what we notice is that, let's say our graph starts at 0, and that period that we're going to look at ends at 2 pi. So what we notice is that the graph is going to hit the 0, or the horizontal axis, at the beginning, the middle, and the end of the period. So we say that sine equals 0 at the beginning, middle, and end of the period. And additionally, the maximum value and the minimum value, that is going to occur at the quarter points. So what we can think of is we can kind of imagine that this period length of 2 pi is split up into 4 equal sections. Okay, so that point at pi over 2, that's 1/4 of a way along the period. And then, can't really see it, but 3 pi over 2 is equal to 3/4 of the period length. So what we have is a max and min values of the curve at, we say, the quarter points. So now let's look at a cosine graph, and it looks very similar. Much like cosine graph, or much like the sine graph, we have the amplitude. Again, the amplitude is just this distance here, this distance here. So in this standard form of a cosine graph, we have an amplitude equal to 1, amplitude equal to 1. And we can think of, again, we can think of the amplitude like a vertical stretch or compression. And we'll see how this relates back to what we saw with any vertical stretch or compression for any other function. So we have the amplitude, and then we also have the period length. And the period length is going to be from 0 here to 2 pi. Okay, so the period length is the exact same as what we saw for sine. So the period length here is going to equal 2 pi. And then similarly to sine, the cosine graph hits 0 at certain points, and it has maximum and minimum values at certain points. So we're going to say that the cosine graph, this is going to equal 0 at, well, it equals 0 here, equals 0 here. So these are at the quarter points within the period. All right, and then the max and the minimum values are at the beginning of the period, the middle of the period, and the end of the period. So max and min values occur at beginning, middle, and end. So what we can notice here is that cosine, where it equals 0, is opposite of where sine equals 0. And where the max and mins occur for sine and cosine are opposites of each other. Now trying to remember where cosine is equal to 0 and where it has a maximum and minimum value, well, if you can think back to the unit circle, all of the values where cosine is max and min and where it equals 0 just fall from the unit circle. So if we can remember some of the coordinates for the unit circle, cosine at 0, well, that is equal to 1, and that corresponds to this right here. Cosine at pi over 2 is equal to 0, so we have right here at pi over 2. Cosine at pi is equal to -1, and that's what we have right here, and so on. So at 3 pi over 2 we have 0, and at 2 pi we have back up to 1. So thinking about the unit circle will help us remember where cosine is max, min, or where it's 0. So one way you can kind of think of a cosine graph, it's kind of like we're unrolling the unit circle. Now the same idea applies for sine. We can think back to the values on the unit circle for sine, and those values will help us remember where the graph is max, min, or 0. I didn't show that on the sine graph just because we were running out of room there. So let's go through the steps we can take to actually come up with the graph. So the first step we want to do is write the equation in standard form. For sine, it's going to be y equals a sine b times x minus c plus d. For cosine, everything is the exact same. The only difference is that instead of a sine function, we have a cosine function. So you really just need to memorize in one of these forms, and you'll be good. Next, we need to find the amplitude, the period, and any shifts that are occurring. So the amplitude is just the absolute value of the a value. Okay. The period length for sine or cosine, we take 2 pi and we divide by the b value. So the b value just from the standard form of the equation. And then any shifts. So the C value corresponds to a horizontal shift, and D corresponds to a vertical shift. Now if we can think back to the transformations we saw in section 2.7, all of these items, the A value, the B value, the C value, and the D value, follow very closely to what we saw with the other shifts. So the easiest one to see is the D value. That's just a vertical shift. That's going to be a shift up or down. The C value, that's a horizontal shift. So we're either, if we see negative C there, that's going to be a shift to the right. If we see plus C, it's going to be a shift to the left. The A value here is just a vertical stretch or compression, so that's going to affect the amplitude. And then B doesn't totally have a corresponding transformation that we saw previously, but the b value just goes into finding the length of the period. All right, so what we do is once we find the period, once we find all of this information, the next thing we do is we take the period and we want to divide that into 4 quarters, and we'll see how this works when we look at an example. But again, we already saw how the 5 key points work. The 5 key points are the max and the min values, also where the zeros are. So for each of these, we need to find the max and min values and then what the zeros are. And then any horizontal or vertical shifts, we apply those to the key points, and then we come up with a sketch of the graph. So the second part of this video is just applying these 5 steps to a series of different examples. Let's go ahead and graph this. Y equals 2 sine 4x plus 1. The first thing we want to do is put this into standard form. So the standard form of this equation is going to look like this. Y equals a times sine b x minus c plus d. Now every equation may not have a non-1 value for a, b, c, and d. So putting this into standard form, we're going to say that we have y equals 2 times sine. Now 4 here is the b value, so we're going to factor that out. There's no c value. I'm just going to put a 0 here, plus 1. Okay, so we have this in standard form. So the reason we do this is so that we can easily identify what the a value is, b, c, and d. Okay, so each of these values tell us something. The a value, the absolute value of the a value, is equal to the amplitude. So the amplitude is 2. The period length, again, is 2 pi over b. So since the b value is 4, we're going to say that the period length is 2 pi over 4, reducing that pi over 2. So our period length is pi over 2. The horizontal shift is going to correspond to the c value. So because c is equal to 0, because c is equal to 0, we would say no horizontal shift. And I made a mistake here. The d value is equal to 1. So since d is equal to 1, we would say vertical shift up 1 unit. Okay, so from here, what we want to do is mark out what the period length is going to look like. So the period, I'll kind of do it over here. So the period is equal to pi over 2. So what that means is on a horizontal axis, if we begin at 0, the period length is going to end at pi over 2. And then what I like to do is I like to split up or kind of separate the period into 4 equal sections. So split the period in half. Half of pi over 2 is going to be pi over 4. And then split it up into each half into 2 equal sections. So half of pi over 4 is pi over 8. And then to get this the third quarter here, sometimes this causes people trouble. But if we just add these two together, we'll get that third quarter position. So the third quarter position, pi over 8 plus pi over 4, get a common denominator. So pi over 8 plus 2 pi over 8, we get 3 pi over 8 here. All right, and again, since there's no horizontal shift, these values that we just marked on the horizontal axis are going to stay the same. They're not going to have any shifting. So from here, let's go ahead and come up with the graph. Actually, let me move that over a little. Okay, so what I'm going to do is I'm just going to mark off those values that I already found. Pi over 2, pi over 4, Okay, and then the amplitude is 2, so I'm going to go up 2 units, down 2 units. And then what we need to remember is that for a sine graph, sine crosses this horizontal axis, which is x in this case. Actually, it's not going to be x because I'm going to shift up 1 unit. So let's back up just a hair. I kind of forgot about the vertical shift. So instead of the graph revolving around the x-axis, the new x-axis is going to be x equals 1 because we're shifting everything up 1 unit. So the amplitude that we're going to have is still going to be 2 units. The graph is still going to go up 2 from this horizontal axis, but up 2 units from 1 is going to be 3, and then 2 units down from 1 is going to be negative 1. Now we can go ahead and mark off the key points for the graph. So sine crosses this horizontal axis at the beginning, the middle, and at the end. And then the max and the minimum values are at the quarter points. Now, because our leading coefficient is positive here, the graph is going to start by increasing. So the maximum value is going to be here, and the minimum value is going to be down here. And then once we have these 5 points plotted, we can go ahead and try to draw a smooth curve in between these points. And again, it's sometimes not the easiest to graph on the screen I'm writing on, but this is the idea here. So this would be what our sine graph looks like. Okay, let's go ahead and graph this cosine graph. So putting this into standard form, what we're going to have is y equals negative cosine. Factor out the b value, so 2x minus, now when we factor out 2 from each of these terms, I need to divide the pi by 2. So this is going to be pi over 2. And then plus 0, we can just put a plus 0 there because we're not going to have any vertical shift. Okay, so that's what the 0 is representing. So we have an a value that is negative 1, b value is 2, c value is pi over 2, and then the d value is 0. So what this tells us is the amplitude is the absolute value of the a. So a is negative 1, the absolute value is going to be positive 1. So there's our amplitude. The period, again, is 2 pi over b. So this is 2 pi over 2, which is pi. That c value tells us we're going to have a horizontal shift. We're going to go right pi over 2 units. It's not enough just to say pi over 2. We need to say which direction this is going in. And then vertical shift, we have none. No vertical shift because we have 0 here. Okay, so next up, what we want to do is plot out the period length. So the period length is pi. So if we begin at 0 and end at pi, let's split this up into quarters. So halfway is pi over 2, half of that is pi over 4, and then if we add pi over 4 and pi over 2, well, that's pi over 4 plus 2 pi over 4, so 3 pi over 4. Now, this is when things sometimes get tricky for folks. We need to shift all of these 5 values to the right pi over 2. So what we're going to do is we're going to add pi over 2 to each of these 5 values. So you need to take your time here. The first one is pretty easy. We're taking 0. We're going to add pi over 2 to that. So 0 plus pi over 2 is pi over 2. Next, we're going to take pi over 4 and we're going to add pi over 2. Well, again, we need to get a common denominator. So pi over 2 plus pi over 4. Well, this is 2 pi over 4, so 3 pi over 4 is what this value is now going to be. So I've shifted pi over 4 to the right, pi over 2. Next, pi over 2 plus pi over 2 is going to be pi. 3 pi over 4 plus pi over 2. Well, this gets us common denominator, 2 pi over 4, 5 pi over 4, and then pi over 2 plus pi is 3 pi over 2. So these are the new values that we're going to use on our graph. So after any horizontal shifting has occurred, these are the values that we use. So going ahead and graphing this, the graph is not going to start at 0, it's going to start at pi over 2. So how about pi over 2 right here? The end of the period is 3 pi over 2. The middle is pi. And then the quarter marks are 3 pi over 4 and 5 pi over 4. Okay, the amplitude is 1 here, and there's no vertical shift, so the graph is going to go up to +1. It's going to go down to -1. And then the leading term here is a -1. So what that tells us is this graph is going to start in the negative portion. It's kind of like it's a vertical reflection, a reflection across the x-axis. Okay, so cosine graph. Cosine crosses the horizontal axis at the quarter points, so it equals 0 at the quarter points, and then the max and the min values are at the beginning, middle, and end. So because this graph is starting negative, we're going to start down here. We're going to reach a maximum value at pi, and then we're going to come back down to 3 pi over 2. So from there, we can just go ahead and smoothly connect these points. And that is one period for this graph. All right, 2 more examples to go. In standard form, this is going to be y equals 3 cosine. There's no b value. The coefficient on x is just 1, so we can put a 1 here. X plus pi over 2 minus 1. So A, we have 3, B is 1, C is, we're going to say that this is negative pi over 2, and then D is -1 here. So finding the amplitude, we have an amplitude, which is the absolute value of 3, so amplitude is 3. The period is 2 pi over b. Since b is equal to 1, we have a period of 2 pi. For the horizontal shift, we are shifting pi over 2, and that's to the left, so we'll say left pi over 2 units. And then for the vertical shift, we're going to say we are going down 1 unit. All right, so let's take a look at the period length. So the period is going to be 0 to 2 pi. Cutting this into quarters, we have pi in the middle, and then pi over 2 and 3 pi over 2. So what we need to do is we need to shift everything pi over 2 units left. So take each of those 5 original values. We're going to say 0 minus pi over 2, so negative pi over 2. We have pi over 2 minus pi over 2 is 0. Pi minus pi over 2 will be pi over 2. 3 pi minus pi over 2 is 2 pi over 2, or just pi. And then 2 pi minus pi over 2 is 3 pi over 2. So this will be the horizontal axis we're going to use, and then we need to shift everything down 1 unit. So here's what our graph will look like. Negative pi over 2 is our starting value, 0, pi over 2, pi, and 3 pi over 2. So 0, so this is the y-axis. So we have x-axis, y-axis. Since we're shifting down 1 unit, we're going to say at -1, that's going to be the new horizontal axis here. All right, so we have an amplitude of 3. So From -1, we're going to go up 3, so 0, 1, 2. And then if we're going in the negative direction, let's extend this. If we're going in the negative direction, make that a little straighter. So we're going down 3 units from -1, so -2, -3, -4. So there will be the max and minimum values. This is cosine. Cosine graph starts out at the maximum or the minimum value, and at the quarter points is where we cross 0. So we're going to cross 0 here and here. Remember, that's -1 is our new horizontal axis. Because the leading term is positive, this cosine graph is going to start out in the positive direction. It's going to cross 0, and then at pi over 2, it's going to equal -4. Then it's going to start to increase again. It'll cross -1 at pi, and then at 3 pi over 2, it'll reach 2. So these are the values we want to connect. So the graph is going to look something like this. Then it'll start to come down again. So that's what our graph is going to look like. Let's clean that up. And there we go. So one final graph for us to look at. So standard form, we're going to say -5 sine, no coefficient on x, and there's no c value here. So the a value is -5, b value is 1, c value is 0, d value is -4. So the amplitude is absolute value of a, so this is equal to 5. The period is 2 pi over b, so just 2 pi. There's no horizontal shift. And then the vertical shift, we're going to say down 4 units. All right, so if we look at the period length is 2 pi. So separate 2 pi into quarters. 2 pi, so we have pi, pi over 2, and 3 pi over 2. No horizontal shift, so these 5 values are going to be what we see on the graph, and then the only shift we have to consider is we're going down 4 units. So let's see what this graph is going to look like. Vertical axis, horizontal axis, so 0, we have 2 pi down here, halfway will be pi, and then the quarter marks, pi over 2 and 3 pi over 2. This is a sine graph. Sine crosses at the beginning, middle, and end. But before we do that, we need to find the new horizontal axis, which will be, we're moving down 4 units. So 1, 2, 3, 4. So at -4, that'll be the new horizontal axis that we're going to revolve this graph around. So sine graph crosses at the beginning, middle, and end. So beginning, middle, and end. And then the amplitude is 5. So from -4, we're going to go up 5 units. So we're going to come up here to +1, and then we're going to go down 5 units from -4, which will be -9. So 5, 6, 7, 8, 9. So the graph, the leading term is negative here. So this graph is going to begin going in the negative direction. It's going to come back up to -4 at pi, and then at 3 pi over 2, it'll hit that maximum value. So again, putting this all together, the graph is going to look something like this.